Okay, welcome. Today we're going to do a brief lesson on integers and absolute value. This is Chapter 1, Section 3. You're watching this from home. And as you're doing this, you are filling out that yellow note sheet that I gave you in class today. So let's just get started with this to keep the video as brief as possible and give you more time to do the other things that you want to do. All right, we're going to start off with some basic information, some vocab terms, and just some information that's going to be relevant for this particular section. First thing here, I have an asterisk next to it. It says you can write quantities less than 0 by using negative numbers. Now, we all know what negative numbers are. You've used them, I'm sure, somewhat to this point, maybe not a lot, but you know that negative numbers exist and that they are less than 0. Now, physically speaking, numbers less than 0 would be to the left of 0 on the number line. And we'll investigate that further in lessons beyond this. All right, the next concept relates again back to 0, but it talks about numbers that are the same distance from 0 on a number line, but in opposite directions are called something. Maybe in your mind you have an idea of what these numbers are called, so I'll give you a second. The correct term here would be opposites. Okay, now if we think about that specifically, if you have numbers that are the same distance from 0, so for instance 3 would be our first number. A number that is also the same distance from 0 would be its opposite, -3. Both values are 3 places away from 0. Or if I tried something different, let's say I had -10, the number that is the same distance from -10 on a number line, I'm sorry, the number that is the same distance from 0 as -10 on a number line would be +10. Both of those would be 10 places away from 0 on a number line. So therefore, these are called opposites. Now let's give a name to the larger family of numbers here. The set of whole numbers and their opposites. This is a very important term. We're going to be using this throughout the year. This set of numbers are called integers. Integers. Whole numbers and their opposites. So these ought to be the numbers that you like to work with here. We're not speaking of decimals or fractions. We're just speaking simply of the whole numbers. 1, 2, 3, 4, 5, -1, -2, -3, etc. 0 is an integer. But the next concept here, it says 0 is its, and then there are 2 blank spaces. You may have an idea of what goes in these spaces, but it's in relation to opposites, we would say that 0 doesn't have a different opposite. We would say 0 is its own opposite. It doesn't make any sense to say -0. It's the same as 0. It's impossible to have a -0 there. So we say 0 is its own opposite. And then the last term in this portion talks about a number's distance from 0 on a number line. Very important concept here. You may have seen this or noticed this term up above, but a number's distance from 0 on a number line is referred to a number's absolute value. I guess I don't know why I put those on 2 separate lines, but either way, absolute value is a number's distance from 0. So, for instance, if I wanted to know the absolute value of 4, there is a symbol or a notation that we use for absolute value. Simply wrap this number in 2 vertical bars like this, and that's asking for the absolute value. So the absolute value, or the distance from 0 on a number line, well, the absolute value of 4 is just 4, because it's 4 places from 0 on a number line. If I wanted to know the absolute value of -4, well, think about how far away from 0 is -4. Well, that is also 4 places away. So the absolute value of negative 4 is also 4. Since absolute value references something called distance, we will always deal with positive values when we refer to absolute value. Distance is not going to be a negative quantity. You wouldn't say that, I walked -5 blocks to my friend's house, or, I walked backwards 10 feet, so I walked a -10 feet. That doesn't make any sense. You are still covering distance, so we're talking about positive values there. And this would also work for variables. Since we are doing a lot with algebra, if I ask for the absolute value of x, regardless of what x is, the absolute value of x is x. Or the absolute value of negative x, or the opposite of x, would still be a positive x. Okay? So we'll see these a little bit further on. There's one more example in between that we have to get to here, and that deals with graphing these numbers on a number line. Very simple task that you guys can all handle, I'm sure. The example says to graph 5, 0, and -4 on the number line below. And the only reason this is on here is just to show you quickly how do you acknowledge 5, 0, and -4 on the number line. Well, if I was graphing 5 on here, it's nice that 5 has a space, right? You can see 5 right there, so there is a location for this. So if there is a specific location for it, all we need to do is just put a dot exactly where 5 would be. Graph 0 on a number line. Excuse me. Zero, clearly on the number line, would be right there. And -4, we're going left of 0. -4 goes down here. All right, so that's it. And those are just 3 integers. I just wanted to show you, if it asks you to graph it, all you're doing is plotting a point on that number line. Okay, moving ahead. What we already talked about already, here are some specific examples. These are on the back of your note sheet. Example 2. It says find each absolute value listed below. Now, even though I specified here in the directions, find the absolute value, you should have known just by seeing this symbol right here, those 2 vertical bars, that that's already asking for absolute value. You know that. So we want to know numbers distance from 0 on a number line. Take a second if you want to pause this to do these on your own and then turn it back on to see what the answers are. I'm just going to go right into the answers. So go ahead and pause if you'd like to. But the absolute value of 6, that number is 6 places away from 0 on a number line, so it's positive 6. The absolute value of -6. Again, that is still 6 places away from 0, albeit in a different direction, but it's still 6 places from 0. So its absolute value is 6. Absolute value of 7 is 7. And the absolute value of -13 is to the left of 0, but it is still 13 places away from 0 on a number line. Okay? So those are the values, or the absolute values, of that set of numbers. This important note here, I tried to emphasize that, but I will do it again here. Since we have been analyzing some order of operations, evaluating expressions and such, I felt the need to clarify that absolute values are treated the same way parentheses are. Because technically, when you're doing order of operations, step number 1 is to evaluate any sort of grouping symbols. Most of the time, we deal with parentheses. However, absolute value, the vertical bars represent another form of a grouping symbol. So do brackets and things like that. But when you see absolute value, you would treat that as the first step in the evaluating or simplifying process. Okay, so for example 3 here, it says evaluate each expression for the given value. And in this problem, it's asking for the absolute value of A. Well, unless we know what the value of A is. We can't really do much with this. We could say that the absolute value of A is A, but for A is equal to -2, we know now what the value is. So what we're going to do is take this value for A and substitute it in. So simply, all you're doing is taking the absolute value of -2, which is 2 places from 0 on a number line, so you're talking about 2. All right, B. Again, absolute value of 2b. Now, we all know that that means 2 times b, the product of 2 and b, for b equals 4. So let's first substitute in what we know. This is the way we should be doing this. Absolute value of 2 times b, which is 4, which, as we simplify further, this becomes the absolute value of 8, which then is, as we know, 8. Okay? And then the last one. I put a number on here that is not an integer. This value right here, -3.5, this is not considered an integer, but yet still a number that we can work with. 3 times the absolute value of c. We know this from before. Anytime you see a number outside of parentheses or grouping symbols without any sort of symbol, that means or symbolizes multiplication. So this means 3 times the absolute value of -3.5. Well, like I said before, you need to do the parentheses or the grouping symbols, which would be here. We need to do this first in the process. Let me move that down. So we would first take the absolute value of -3.5, which, regardless of whether it's an integer or a decimal or a fraction, whatever, we treat it the same way. So the absolute value of -3.5 is still +3.5. So then we would take 3 times 3.5 and give you a product of 10.5. Okay? So that's simply how you would evaluate expressions that involve order of operations, or involve absolute value, rather. Okay? The next objective, objective 2, talks about comparing and ordering these numbers and integers. This one's a very brief section and something you'll pick up very easily, I'm sure. Let's fill in the blank here. It says numbers blank as you move to the right on the number line and blank as you move to the left. I'm sure you could probably fill this in on your own, but think about, and no matter where you begin on the number line, if you start moving to the right of that starting point, what is happening to the numbers? And hopefully you're answering that these numbers are increasing as you move to the right. Again, no matter where you start. I could start at 0, I could start at 100, I could start at 1,000,000, I could start at -1 million. If I'm moving to the right, the numbers are getting progressively bigger. Likewise, and they would be decreasing, or they would decrease as you move to the left. All right, the last little note here, a positive number is always blank in a negative number. So if you're comparing two numbers, one's positive, one's negative, it shouldn't be that difficult of an assignment since a positive number is always greater than a negative number. And I'm sure, I know you know that. Okay, example 4. So now we just need to order -2, -3, 0, -6, -7, and +7 from least to greatest. These are not absolute values. These are the values, and we just want to order them from least to greatest. So thinking in terms of a number line, we know that numbers increase as you move to the right and decrease as you move to the left. So we're looking for the least value, or the smallest value. Well, by that logic from up above here, up in this area up here, the number that is the least should be the number that is the furthest to the left on the number line. So imagine a number line, counting backwards. The smallest number, or the number to the farthest left, would be -7. As you move to the right, they get larger. So -7, next in line, getting larger, would be -6. I like to cross these off so I don't forget any. The next number we have, The only other negative we're looking at here is -2, and we already know that negatives are greater than any positive, or excuse me, positives are greater than any negative. So you have -2. That's gone. Then we're left with 0, 3, and 7. Well, we know 0 is smaller than 3, which is smaller than 7. Okay, so there's just some basic number sense ideas that I gave you, but ones that hopefully you already knew, and if not, you're going to apply those as we go forward here. All right, very last example here. Give you a little table. This is just some application of how we apply these negatives and comparing and ordering. The question simply says, which continent had the lowest recorded temperature? When you look at those numbers right there, at first glance, you start looking at the lowest recorded temperature, you may look right there. Because -9, you see 9. 9 is the smallest, or has the smallest absolute value of all of those numbers, but it's not the smallest value or the lowest temperature. The lowest temperature, as we talked before, would be the one that's furthest left on a number line, or thinking in terms of a thermometer, the one that is furthest down. If we look very closely, we see this Antarctica, which shouldn't really come as a surprise to anybody, being the coldest temperature, at -129. There are none of these other numbers can rival that in terms of the temperature as being the coldest. The next one says the highest temperature. It may seem sort of odd, but that number that I highlighted earlier would be located furthest to the right on a number line. So Australia at -9 degrees would actually have had the highest temperature in this chart right here. All right? So that's how we would compare and order these integers. So tonight, your task was just to watch this video and fill in this note sheet, which hopefully you've been doing. And that's it. Tomorrow we'll come into class, we'll do some practice with this, and give you an opportunity to ask any questions on this. All right, guys, have a good night. Talk to you tomorrow. Bye.